Alright, let's look at this homework problem in 4A. This is going to be a good problem for you to practice the 6-step approach we learned in class. Okay, let's first look at this problem. In this problem, we have two blocks, two masses. One's A, one's B. They're connected with rope and pulleys. And mass A is sitting on a slope, and this slope has an angle theta. And in this problem, we're given the mass for MA and MB. We're given the friction coefficient here, mu K and mu S. Mu K is a kinetic friction coefficient, and mu S it's the static friction coefficient. And here we have several things we need to find out. First thing, we need to find out what is the normal force NA. And second thing, it's to find the tension inside of the rope. And the third one is to find the maximum force that can pull in the rope without moving the block A. And number 4, we need to find the ratio between AB and AA. Here A is the acceleration of both masses. And number 5 and 6 are looking for accelerations. Okay, let's look at this problem together. Of course, you need to use the 6-step approach to solve this problem. And in step 1, we need to draw a free body diagram for both masses. Okay, and make sure you draw them separately. We only care about the mass here, so you don't need to draw free body diagram for the pulley for the rope. So here we have block B. Block B is hanging with the rope, so there is a tension force, let's call it FTB. And of course there's a weight force, let's call it WB. That's the free body diagram just for the mass B. And for mass A, we have more forces on mass A. Of course, we have weight force, that is WA, and we also have a tension force from the rope. It's pulling the block, the mass. Let's call it FTA. Then, because mass A is sitting on the slope, right? And there should be a normal force that perpendicular to the slope surface. So here we have a normal force NA. Alright, make sure you add vector for all the forces. And there's one more force for block A. And since there is friction coefficient between the block A and the surface, therefore there must be friction forces, either pointing downwards or upwards, depends. But here we just assume the friction force is pointing down the slope. Okay, so here it's a step 1. You need to draw the free body diagram for each mass in the problem. Here we only have 2 masses, so 2 free body diagrams. If you have 3 masses, make sure you draw 3 free body diagrams. Right, now let's move on to step 2. In step 2, we need to set up coordinate systems for each mass. In this case would be for A and B. I will use red color for coordinate system. And since block B is hanging with the rope on the rope, so I would just use the traditional classic X and Y direction. So we have y and x. And block A is sitting on a slope with an angle. So I would set my x coordinates perpendicular to the surface of the slope. In order to differentiate two different coordinate systems, I will use big X and big Y for block A. Okay, now we finished step 2. Let's move on to step 3. Step 3 is to set up, it's to write all forces in vector form. And make sure you do this for both masses and do them separately. And here I would list mass A and start to write forces for mass A, and here is for mass B. And in order to make sure you have all the forces in vector form, I would suggest you to do step 3 by referring to your free body diagram. If you look at your free body diagram, and you will see how many forces you put there for mass A and mass B, and make sure you have all the forces in vector form.